Hey everybody, welcome back. I hope you're excited. I hope we're ready to go. You got that pencil sharpened, the brand new eraser. I love the smell of math textbooks in the morning. Woohoo! I hope you're set to go today. Today we're going to start with Chapter 1, Lesson 1. Oh my goodness, we get to start with Lesson 1 of Chapter 1. I hope you're set to go. All right, here we go. Here are 5 warm-ups that I'd like you to start right off the bat. I want you to give these all 5, give these your best, and we will correct them in just a second. So pause the video right now, give these 5 a shot, and we'll get going. Woohoo! Alright, here we go. A lot of these have to do with the order of operations. So don't forget, please excuse my dear Aunt Sally. You have your parentheses, your exponents, then you have your multiplication, division, addition, and subtraction. We'll get to that in just a second, but we'll see how you did on the first few warm-ups. So the very first thing you have to do on number 1 is you have to take 2 times 3, which is 6. 21 minus 6 is 15. 15 is your answer for the very first one. Then, again, number 2, order of operations. You have to take multiplication before you add. You can't take 4 plus 3. You have to take 3 times 9 first to get to 27. And then we add 4 plus 27 to get your 31. Alright? Next, again, we have multiplication and addition. Multiplication always comes first. 18 plus 3 is going to be 21. Now we get to deal with a little bit of decimals. Don't forget that it is essentially the exact same thing when you're multiplying decimals together. So when you do this, you take 6 times 1.4, which is 8.4. Then you're going to add 12 there, and that's going to be 20.4. Okay, number 5 is very, very similar to number 4, except this time we have a little subtraction here. So we take 7 times 2.9 to start off with, and you get 20.3. We now take that 20.3 and subtract 5, and we get our answer of 15.3. So there's our first 5 warm-ups. I hope your brain's getting moving. I hope you're starting to remember things in math again. I hope you never forgot it, of course. But these 5 math problems are just to get your brain moving, get your brain going a little bit and thinking about math. All right? Awesome. Here we go. Today we're going to be talking about evaluating algebraic expressions. And the very first thing we have to do is figure out some vocabulary words. We're going to figure out what a variable, coefficient, algebraic expression, constant, evaluate, and substitute. All of those vocab words, we're going to be writing them down, and we're going to get to know them. So notice right up here, okay, you will see this yellow bar right here. Notice how beautiful that yellow bar is. It's like the sun. The sun is so bright. So those yellow bars, they brighten up your day because they tell you which notes to write down, okay? So whenever you see this beautiful sun-like yellow bar, it looks like the sun just brightens up your day. That yellow bar brightens up your day because it tells you, hey, I need to write this down. So anytime you see a yellow bar like that, please write it down, all right? So I want you to pause the video right now and write down variable and coefficient, all right? All right, here we go. A variable is a letter that represents a value that can change or vary. Okay, so variables, you might see variables all over math. You may see, remember, you may be dealing with x's or y's or even z's. You may see an n, an a, a b. Anytime you see a letter is known as a variable in math. Okay, so you're going to be seeing these different variables all throughout this lesson and all throughout the year. The next thing is a coefficient. A coefficient is the number multiplied by the variable. If you look down below, okay, here's an example of a coefficient and a variable. Notice the coefficient is the number out in front of the variable. This variable is that n right there. That variable should be moved over a little bit. But the coefficient is that number in front of the letter. And what that's saying is whenever you see a coefficient and a variable, it always means multiplication. You always take, if I look at 30n, those two mean 30 times n. Whenever you see a coefficient in front of a variable, where they're connected, we're talking about multiplication. Okay? Again, we're going to see a lot of that. All right? Moving on. Next, we have algebraic expression, constant, evaluating, and substitute. What I want you to do is, again, pause the video right now and finish these words. So pause now, finish them up. All right. So right now we're going to be talking about an algebraic expression. An algebraic expression, an expression with one or more variables. So if you see a variable, at least one variable, so it could be 30n, that is an algebraic expression. If you look at x plus 7 is an algebraic expression, all because we have a variable out front, or a variable in the equation. That doesn't look like an n, but it is. That is an n. Okay? If you even have an expression that looks like d plus c, that is a algebraic expression. What makes it an expression is, notice there is no equality signs. There's no inequality signs. There's no equal sign here at the very end. Okay, because that's a little bit different. An expression does not have an equality sign, or it does not have an inequality sign. Okay, it's just the expression of x plus 7. Okay, a constant is a value that does not change. So if I look at this, if again I pull out that algebraic expression of x plus 7, your constant is this 7, because no matter what you look at, that 7 is always going to be 7. Okay, what can change is your x. We don't know what x is. We know what 7 is, but we don't know what x is because I don't have any parameters for that. So a constant is a value that does not change, and in this algebraic expression, this right here, that 7, will not change. All right? Last two, evaluate and substitute. Evaluating is just saying find the value of an expression. Basically, answer the problem. So whenever you see evaluate, think answer. Answer, evaluate, evaluate, answer. What does evaluate mean? Answer. It means answer. Yeah, absolutely. All right. Next one is substitute. All right. When we substitute, all we're doing is we're replacing a variable with a numerical value. Okay, so for instance, let's keep going back to this x plus 7, because this is a very good example, if I do say so myself. Okay, let's say x is equal to 2. Wherever I say whenever I mean substitute, I mean when I have this right here, that x is equal to 2, I'm just going to take this 2 and substitute it in for x. Because in this expression, this algebraic expression, x is 2. Wherever you see an x, you can put a 2. All right? We're going to go through some problems right now. All right? Hope you're excited, because I am. Here we go. In just a second, we're going to get to problems. What I want you to do is write these orders down. Okay? Memorize them. Read them before bed. Dream about these operations because they are so wonderful. Okay? So please write this down, and I will explain. All right. So if I look at my order of operations, you can use that phrase, please excuse my dear Aunt Sally, meaning parentheses first, then exponents, then you multiply and divide, and then you add and subtract. One thing that gets a little bit confusing, okay, if I look at the expression of 9 divided by 3 times 3, if I look at this expression, well, if you go by please excuse my dear Aunt Sally, a lot of people would say you have to do this multiplication first. Okay? But that's not right. Okay? What we have to do is we have to go from left to right. We always go from left to right if I'm dealing with just two operations. Essentially, if I'm just dealing with multiplication and division, or if I'm dealing with addition or subtraction. Okay? Again, whenever I deal with an expression, or with just multiplication and division, I have to go from left to right. I have to. Okay? Or if I have an expression of addition and subtraction, I have to go from left to right. Okay, so in this problem, I would take 9 divided by 3 first to get 3, and then I would multiply 3 times 3, and I would get 9. Okay, so watch that left to right rule. That's a common mistake, and I just wanted to point that out. All right, here we go. Now let's get into some problems. All right, notice this yellow bar that brightens up your day. You don't need to worry about that word example 1. Don't worry about those. But that yellow bar, I want you to write down the directions and then write down each problem. Once you're finished with those, okay, I want you to try to see if you can do those problems. If you're not sure, that's all right. I will explain it in just a moment. All right, so pause the video right now, write down everything, and give these 2 problems a shot if you think you know how to do them. All right, go ahead. All right, here we go. If I'm looking at this, again, I'm looking at x minus 5 for x is equal to 12, okay? So if I look at that, well, if I know x is equal to 12 and my expression here, my algebraic expression is x minus 5, all I'm going to do is I'm going to take this 12 and I'm going to put that 12 in for anywhere I see a 5 and x. Anywhere I see an x, I plug that 12 in. So if I look at x minus 5, well, I see an x right there. My expression becomes 12 minus 5 because I substituted in that 12 for an x. 12 for an x, so now I have 12 minus 5. My answer is 7. Perfect. Okay, next problem. And I'm done. I have 7. It's a lucky number, by the way. Okay, now the other problem. 2y plus 1 for y equals 4. Again, it gives me a key here. This is like our key, y equals 4. So that tells me in this problem, anywhere I see a y, I plug in a 4. Okay, so I see a y right there. I'm going to plug in a 4. Now, what operation happens when I have a coefficient and a variable next to each other, right next to each other, like that 2y? What operation is happening between the 2 and the y? Multiplication. Awesome. So now I have 2 times y, right? Well, y is 4. So I have 2 times 4 plus 1. Okay, 2 times 4 plus 1. Order of operations, I have to do multiplication before I add. So I take 2 times 4, 8, plus 1. When I take 8 plus 1, I get 9. My answer is 9. Okay, so again, I plug in that 4 for wherever I see a y, and then I answer the problem according to the rules of PEMDAS. All right? All right, here we go. Moving on. This one, I want you to try this problem all by yourself. I'm not even going to I want to see if you can do it. I'm not even going to start directing you. Besides, I want you to answer it for where n equals 5, where n equals 6, and where n equals 7. And we'll see how you do. Okay? So, think about what you have to do and do it. Pause the video now. All right, here we go. So, I have 6, and in parentheses, I have n plus 2, and then I'm subtracting 4 in the end. Okay, if I look at this, remember, when my number is right outside that parentheses, I'm talking about multiplication. So I'm multiplying that 6 with whatever is happening inside those parentheses. And I'm going to have 3 different answers because I have to do it for 5, 6, and 7. All right, so let's start with 5. Let me take 6, and then wherever I see an n, I'm going to plug in a 5. 5 plus 2 minus 4. Okay. I plugged in my 5, and now I'm just solving this problem. What is 5 plus 2? Because remember, I have to do inside the parentheses first. I get 7. 6 times 7 minus 4. What do I do first? Multiplication. I need to take 6 times 7, which is 42, minus 4, and I get 38 as my answer. Okay, all done with the first one. Next, I need to plug in a 6 this time. Plug in a 6 where I see an n. So I see an n right inside the parentheses. 6 times the sum of 6 plus 2 minus 4. Ooh, that's bad parentheses there. There we go. Parentheses right there. So I have 6 times the sum of 6 plus 2. All right? When I do the inside the parentheses first, don't forget order of operations. I get 8 times 6. Still continue on. Now I take 6 times 8, which is 48, minus 4, and my overall answer is going to be 44. Last but not least, I have my 7. So now I'm going to plug in 7 wherever I see an N. Okay, so again, I have this 7. I'm going to take this 7, plug it where I see an N. So I get 6 times 7 plus 2, 7 plus 2, minus 4. Again, inside my parentheses first, 7 plus 2 is 9. 9! It is 9. So I have 6 times 9 minus 4. What do I do first? 6 times 9 is first, because that's what it says in my order of operations. So I have 54 minus 4, and I get my answer of 50. All right, so if I look at that, the very first thing I had to do was inside my parentheses. Inside my parentheses. So I took 5 plus 2, then 6 plus 2, then 7 plus 2. Then I multiplied, then I subtracted. Okay, don't forget order of operations. Order of operations. All right, sweet. Moving on. Okay, what I want you to do is I want you to try this one by yourself. Make sure that you write down directions and write down the problem. Okay. If you're not quite sure on what to start with, what to do, okay, you can just wait. I'll get back to you in just a second and show you how to do this problem. If you think you know how to do it, give it a shot. Give it a try. Good luck. Pause now. All right, so it says evaluate each expression for the given values of the variables. Whoa, hold on. It says evaluate. What does evaluate mean? Answer. Very simply put, answer. So you're just going to answer the expression for the values of the variables. Okay, what's a variable? Letter. It is a letter, absolutely. Okay, so R and P, those are my two variables. Okay, now it says 9R minus 2P for R is equal to 3 and P is equal to 5. What do I do? That's my question. What am I going to do right off the bat? Tell me. All right, okay. We'll see if you're right. Okay, what you're going to do is you're going to substitute this 3 wherever you see an R and this 5 wherever you see a P. Okay, so I have 9R minus 2P. I take 9. And R is the same thing as 3, and P is the same thing as 5. So I have to plug in my 3 at my R, and I plug in my 5 wherever I see P. Now I answer. What do I have to do first? Multiply. I need to multiply first. I take 9 times 3, which is 27, minus 2 times 5, which is 10. And now I subtract. 27 minus 10, 17, and I'm done. Okay, again, substitute first, then go through order of operations. All right? All right. Okay, all I wanted to do, I wanted to show you this. You do not have to write it down. Notice there is no yellow bar here. It is a light blue bar because it's just a blue. I know you're sad you don't have to write this down. I know it's hard. But I just wanted to explain this problem a little bit, and then I'm going to give you your homework. All right? Here we go. So it says use the expression of 1.8 C plus 32 to convert the boiling temperature for degrees Celsius to degrees Fahrenheit. So boiling point of water at sea level. Even though you may know this right off the bat, I just kind of want to explain this in that context. All right. So it says 100 degrees Celsius. So what do? Well, if I have the algebraic expression of 1.8C plus 32. This C stands for degrees Celsius. And what I'm going to do is I'm going to convert the degrees Celsius into degrees Fahrenheit. Okay? So I want to figure out, well, if water boils at 100 degrees Celsius, what does it boil at for Fahrenheit? And I do that by substituting things in, and I take 1.8, and I'm going to put 100 because I want to see what it is as Fahrenheit. Okay, I plugged in that 100 degrees Celsius because C stands for Celsius. When I do that, I get 1.8 times 100, which is 180 plus 32. 180 plus 32 is 212. Don't forget, this is a little bit of a story problem. We are talking about degrees Fahrenheit. Do not forget your labels. Label, label, label. Okay, so 212 degrees Fahrenheit is your answer. All right, again, didn't have to write that down. If you did, fantastic. If you didn't, fantastic. All right, we are done for today. I'm going to give you your assignment later. What I want you to do is maybe go back, recheck those notes. If you have any questions, make sure to ask me when you see me next, which is probably tomorrow. Okay, so ask me any questions that you have about these notes. I'm going to give you the assignment next time I see you. Fantastic. Bingo, bango, bongo. We're done. I hope you liked it. Bye.